Good evening and welcome back. Tonight we will spend some quiet time with the galaxy we live in and with the gentle question of what shape it really has when seen from the inside. The Milky Way is familiar in the broadest way, and yet it is also strangely hidden from us. We stand within it, like someone trying to understand the shape of a forest while walking softly between the trees. If you enjoy these calm journeys through space and science, you can feel free to subscribe, and if you'd like, leave a comment about where you're listening from tonight, or what quiet subject you'd like to drift into next. For now, let the room settle around you. Let the light grow softer. There is no hurry here. We are going to move slowly, following faint starlight, old measurements, and the patient work of astronomers who learn to read the sky the way one might read a map folded many times. And as we begin, imagine a dark sky above a sleeping world and a pale river of light stretched across it, so familiar that we almost stop noticing it until we remember that it is home. The first thing to know is that the Milky Way does not reveal itself all at once. From Earth it appears as a pale band, a mist of stars and dust, crossing the sky like a quiet seam. In some places it seems bright and crowded, in others it fades to a dim wash, and in still other places it is broken by darkness, as if someone had gently brushed soot across the heavens. That darkness is not emptiness. It is part of the structure itself. It is dust, cold and thin, drifting between us and the more distant stars, softening the light and hiding pieces of the galactic interior from view. Long before telescopes, people looked up and saw that band as something living or sacred or simply mysterious. Different cultures gave it different names, and even when the names changed, the feeling remained similar. There was the sense of a great luminous road overhead, a celestial stream, a path of milk, a river of stars. The sky was not yet a diagram. It was a presence, and that feeling still lingers even now when scientific language has given us better tools. Yet tools do not remove wonder, they simply let wonder become more detailed. The Milky Way is a barred spiral galaxy, which sounds technical, but the phrase hides a very graceful idea. Imagine a broad whirl of stars, gas and dust, slowly turning around a center. Not a perfect pinwheel, not a rigid wheel, but a living, uneven spiral, with arms that curve outward and inward at the same time. Near the center, there is a bar-like concentration of stars, stretching across the core. From that bar, the spiral arms unfurl, though not always neatly, and not always in the way a textbook sketch might suggest. Real galaxies are softer, messier, and more subtle than their clean illustrations. Our own galaxy is large, but not unimaginably large in the way the number itself can sometimes feel. It is estimated to contain hundreds of billions of stars, perhaps more, and around those stars, countless planets, moons, clouds of gas, and the uncountable small motions that make a galaxy feel less like a machine and more like a weather system that has been moving for ages. If you could step far outside it and look back, the Milky Way would be a broad disk, flattened by rotation, with a central bulge and spiral arms winding around it. But because we are inside the disk, we do not get the easy view. We have to infer the shape from clues. That is one of the quiet pleasures of astronomy. Often the greatest truths are not seen directly. They are assembled. Astronomers learn to map the galaxy by measuring star positions, distances, motions, colors, and the faint radio signals that pass through dust more easily than visible light. They traced regions where gas was concentrated. They noticed patterns in the places where young stars were forming, and in the old stars that marked the thicker inner regions. They followed the spiral arms the way a traveler might follow the curve of a river at dusk, never seeing the whole river at once, but recognizing its direction from the way the land changes along its banks. In the middle of all this lies the galactic center, a region hidden from ordinary sight by dense clouds of dust. In visible light, it is obscured. But in infrared and radio observations, a different landscape appears. There, behind the veil, astronomers found a powerful and crowded region, with stars packed tightly together and a supermassive black hole at the center, known as Sagittarius A. The name may sound severe, but the reality is not a storybook monster. It is a massive concentration of gravity, quiet and immense, influencing the motion of nearby stars in ways that reveal its presence. This is one of the wonderful things about the hidden shape of the Milky Way. Some parts are impossible to see directly, and yet they still leave fingerprints everywhere. The galaxy rotates, but not like a rigid plate. Different regions move at different speeds, and stars follow long paths around the center over immense spans of time. Our Sun is one of those stars, traveling in its own orbit around the galactic center, far from the core, in a quieter neighborhood sometimes called the Orion Arm or Orion Spur. We are not in the busiest part of the galaxy. We are out on a modest lane between larger structures, in a region where the night sky can appear open and calm. From here, the dense inner galaxy is mostly hidden by distance and dust, and that makes our perspective both limited and useful. Limited because we cannot stand outside ourselves. Useful because the difficulty has forced generations of observers to think carefully. The Milky Way's shape was not understood in a single moment. It emerged slowly as one generation refined the maps of the previous generation, and as each new instrument opened a slightly different window. Early telescopes showed star clusters and nebulae with more clarity than before. Later, photographic plates let astronomers compare patterns across the sky. Then came radio astronomy, which listened to the universe in a new language. Dust that blocked visible light could not block everything. The hydrogen gas threaded through the galaxy emitted radio waves, and those waves carried information about structure, motion, and distance. There is something very peaceful about the idea of listening to a galaxy. Imagine for a moment the thin spread of hydrogen through the spiral arms. Imagine clouds of gas, so cold and diffuse that they seem almost like the idea of a substance rather than a substance itself. And yet within those clouds, gravity gathers matter little by little. Stars are born, not all at once and not in haste. They gather in clusters. They shine and their light pushes back on the surrounding dust. Some of them live briefly and brightly. Others endure for billions of years. The galaxy is always changing, though the change is so slow that a human life feels like a single breath near a mountain. The spiral arms themselves are often misunderstood as solid structures, but they are more like regions of density, patterns that move through the disk. Stars enter them and leave them. Gas compresses there, and star formation is encouraged there. The arms are not frozen decorations. They are places where the galaxy seems to be leaning into new light. And yet, from our point of view, the arms are difficult to trace with confidence because we are inside one of them, peering across the disk and through dusty corridors. That means the galaxy around us can feel both intimate and elusive. The stars in the sky are nearby and remote at once. A bright point of light may be a star not very far from us, or it may be a luminous giant located much farther away. The sky offers clues, but not always answers at first glance. So astronomers ask careful questions. Which stars are clustered together? Which clouds glow in hydrogen emission? Which regions show newborn stars and which hold older populations? How does the movement of stars change from one part of the disk to another? How can we use parallax, proper motion, spectroscopy, and radio measurements to build a map from inside the map itself? It is a patient kind of science, a quiet kind, and perhaps that is why it feels so suitable for a night like this. When we imagine the Milky Way in a simplified way, we often picture one bright spiral seen from above. That image is not wrong, but it is incomplete. The true galaxy is layered. There is the thin disk where many of the bright spiral features appear. There is the thicker disk populated by older stars. There is the bulge near the center where the light grows denser and more complex. There is the surrounding halo, a faint, extended region with older stars, globular clusters, and dark matter whose presence is inferred through gravity rather than directly seen. Dark matter is one of those quiet, astonishing ideas that almost invites a whisper. It does not shine. It does not absorb light in the usual way. It does not announce itself with color, and yet it helps hold the galaxy together. The visible stars alone do not account for the way the galaxy rotates. Something unseen adds mass, shaping the motions of stars and gas. We do not know exactly what dark matter is, at least not yet, but we know that its influence is real. The hidden shape of the Milky Way is not only hidden by dust, it is also shaped by unseen matter distributed in ways our eyes cannot directly perceive. There is a soft humility in that fact. Much of the universe asks to be known indirectly. We infer its presence from the way it bends a path, warms a cloud, shifts a spectrum, tugs on a star. We are not given the whole answer in a single glow. Instead, we receive many small hints. Even the sun's neighborhood has its own gentle structure. Nearby stars drift at modest distances, forming little associations and moving groups. Open clusters dissolve over time, their stars spreading apart like seeds carried by a slow wind. The local interstellar medium contains pockets of gas and dust, bubbles carved by old supernovae, and spaces that are more open than others. The region feels calm when compared to the crowded center, yet even here nothing is truly still. A galaxy is a place of motion layered on motion, and when you think about it long enough, that can feel strangely comforting. To understand the hidden shape, scientists have had to become translators. They interpret light, they interpret motion, they interpret color. A redder star might be cooler or more dust-obscured, while a bluer star may be younger and hotter. By observing many stars together, astronomers can infer where star formation has recently occurred. By measuring the Doppler shift of gas clouds, they can estimate how fast different regions move toward or away from us. By combining methods, the large design begins to appear. In the 20th century, this work gradually transformed the Milky Way from an uncertain mist into a known galaxy with recognizable structure. Before that, there was genuine debate about our place in the universe. Was the galaxy the whole universe? Were spiral nebulae outside it? Was the sun near the center or not? Each question carried a kind of quiet tension, not dramatic in the theatrical sense, but profound in the human sense. To locate ourselves accurately is to change the scale of everything. Eventually, the broader picture emerged. We are not at the center. We are not at the edge in a simple way either. We are somewhere in between, in a particular orbit, at a particular distance from the galactic center, moving with the rest of the disk through a cosmic environment much larger than our daily life. And still, the sky above us is made of intimate things. The same stars seen by ancient observers are still there, though not always in the same arrangement because of our movement through space. The constellations are local patterns, temporary as patterns go, created by our own perspective. The Milky Way itself, however, is the grander framework behind those patterns. It is the stage on which the constellations appear. If you were able to float above the disk, far enough away to see the whole galaxy, you would notice that the bright spiral arms are not evenly bright everywhere. Some segments are more prominent than others. The central bar has its own geometry. Dust lanes trace dark curves along the inner regions. Star-forming clouds cluster in places where the spiral structure compresses material. Giant molecular clouds, dense reservoirs of gas, form the raw material for future stars. All of this adds texture to the hidden shape, like folds in fabric seen from a slight angle. The galaxy is not a perfect drawing. It is more like cloth that has settled naturally under gravity, with tension and softness in different places. And because we live inside it, we are also inside its weather. That weather is slow, of course. It is made of radiation, magnetic fields, gas flows, and the long-term motion of stars. Supernovae erupt and enrich the interstellar medium with heavier elements. New stars are born from that material. Some of those stars will one day end their lives in turn, seeding the galaxy again. Over billions of years, the galaxy recycles itself in a grand, almost gentle loop. Not gentle in the sense of always peaceful, because space contains violence too, but gentle in the sense of vast time smoothing out the drama into pattern. A human night is short. A galactic night is not something the universe has in the same way we do. Yet the idea is still useful. You could think of the galaxy as a place where creation happens so slowly that it resembles patience, and destruction happens so widely that it becomes architecture. In the outer regions, stars orbit more loosely and the disk thins. The halo becomes more prominent in the imagination, though less visible in ordinary light. Globular clusters, those ancient balls of stars, orbit far from the center, carrying hints of an earlier stage in the galaxy's life. Some may have formed along with the Milky Way. Others may have been captured from smaller galaxies that were pulled in and gradually absorbed. The Milky Way is not only a stable home, it is also a record of past mergers, of smaller systems that were once separate and are now part of the larger whole. This, too, is part of the hidden shape. Not only the shape you would draw from the outside, but the shape made by memory. The galaxy contains evidence of old collisions, stretched streams of stars, faint structures in the halo, and chemical signatures that reveal different origins. Astronomers study these traces the way historians study old ink, worn stone, or layers of paint. The story is not written in one place. It is scattered through the structure itself. Sometimes the most interesting questions are not where something is, but how it became that way. The Milky Way's disk likely changed over time as stars formed, moved, and interacted with gas. The central bar may have influenced the flow of material inward and outward. Spiral arms may come and go in prominence. The galaxy might have a more dynamic and evolving shape than a simple classroom model suggests. Some features are more transient than they first appear. Others endure for long eras, though not forever. And because we are inside the process, we cannot watch it like a movie from beginning to end. We can only gather still moments and build from them. There is also the matter of scale, which can be soothing if you let it be. A light year is not a unit suited to ordinary life, and yet it gives the sky a kind of calm mathematics. Light crosses about 9.46 trillion kilometers in 1 year, and across that distance the nearest stars still seem close in the evening sky. The Milky Way is vast even by the standards of galaxies, but among the billions of galaxies in the observable universe, it is one among many. That thought can make a person feel small. But smallness is not the same as insignificance. It simply means we are nested within larger things. Tonight you do not need to solve the galaxy, you only need to drift alongside it. So picture the dark band overhead again, that old pale river across the sky. Now imagine that river not as a single ribbon, but as a slice through a much larger structure, a disk with depth, dust, and hidden curves. The bright area you see is not the whole galaxy. It is only the part of the spiral arm visible from our position. The true shape continues beyond what the eye can make out. Its center lies far away. Its outer edges fade into faintness. Its halo stretches even farther, where the stars become sparse and the darkness grows deeper. And yet the whole thing remains home. Perhaps that is the most quietly astonishing idea of all. We are not looking out from outside a galaxy at a neatly arranged object. We are inside a system that formed long before human beings, long before Earth had oceans, long before our sun was born. The galaxy is older than our species by an almost unimaginable span, and still we have managed to sketch its form, to listen to its gas, to follow its stars, and to understand that what looked like a simple band in the sky is actually a vast, rotating city of light and shadow. A city is a useful metaphor, as long as you remember that this city has no streets in the ordinary sense, no walls, no doors, and no single center for everyday life. Its neighborhoods are made of stars. Its lanes are made of gas and dust. Its old districts are crowded with ancient stars and clusters. Its outskirts are quieter, thinner, and less intensely lit. The center is dense and energetic, while the outer arms are more spacious. Yet from any one address, the larger layout is difficult to see. We live in one of the quieter neighborhoods, looking inward through layers of dust toward a bright and complicated center. The dust lanes along the inner galaxy can block visible light so effectively that they hide entire regions. That is why infrared astronomy became so valuable. Infrared light, with its longer wavelength, can pass through dust better than visible light, revealing stars and structures otherwise concealed. It is as if the galaxy had been speaking in whispers, and at last we learned a different way to listen. Some of the first clearer views of the center were deeply exciting to astronomers, not because they saw everything at once, but because they saw enough to know they were finally approaching the hidden architecture. Star counts, infrared surveys, radio maps, and precise measurements from space-based observatories each contributed another layer. The picture sharpened, then sharpened again. Still, the galaxy remains partly mysterious, because the more precisely we know one region, the more clearly we see the limits of our knowledge in another. That is often how real understanding feels, not final but spacious. If you were to watch the night sky for a long time from a dark place, away from city lights, the Milky Way would slowly become more detailed to your eyes. You might notice its uneven brightness, its mottled appearance, the way a dark lane cuts through it in some regions. You might see clusters and a scattering of bright stars embedded in the glow. The longer you look, the more texture appears. It is one of the gentlest lessons the sky can offer. Attention reveals what haste misses. And perhaps that is why the galaxy is such a fitting companion for bedtime. It does not ask to be conquered. It asks to be observed slowly. Think of the astronomers who worked before powerful space telescopes. They had to rely on long nights, careful notes, and a willingness to be patient with ambiguity. Many drew maps that were incomplete but still beautiful in their own way. They trusted the accumulation of evidence. They trusted that the shape was there, even if their instruments could not yet show it clearly. In time, better technology confirmed some ideas and revised others. Science, in that sense, is a very human form of quiet revision. The Milky Way also reminds us that our home is not static. The sun will keep orbiting. The galaxy will continue to change. Nearby stars will move. Dust clouds will coalesce and disperse. Spiral patterns may shift. In the far future, the Milky Way will interact with the Andromeda galaxy, though that event lies so far beyond ordinary experience that it belongs more to cosmic time than to practical concern. Still, it is comforting to know that even galaxies have histories and futures. They are not frozen monuments. They are living structures in time. There is a strange tenderness in that idea if you let it settle. The hidden shape of the Milky Way is not a secret in the dramatic sense. It is more like a form that only becomes visible from enough angles, with enough patience and enough different kinds of light. It is hidden the way a coastline is hidden from someone standing in the middle of a forest. The land is still there. The shape is real, but perspective matters, so we use the methods available to us. We measure distances with parallax. We track stellar motion with precision. We compare spectra to learn composition. We listen to radio emissions from hydrogen. We observe the dust lanes that outline the inner spiral. We map the distribution of young stars and the older populations that trace the broader disk. And slowly, very slowly, a home we cannot step outside of begins to feel more knowable. The more the galaxy is understood, the more elegant it becomes. Not because it loses mystery, but because the mystery has structure. And perhaps you can feel that structure now as a kind of quiet spatial thought, a vast disk turning in the dark, a bright core wrapped in dust, spirals winding outward. An orbit where the sun travels with patient company, ancient stars in the halo, new stars forming in clouds, invisible mass shaping the whole, a home so large that it takes the whole sky to suggest it, and still the suggestion is only partial. If you are already beginning to drift, you can let these images blur softly at the edges. The galaxy does not need to remain sharp to remain beautiful. In fact, a little softness may suit it better. Far away, the spiral arms fade. The center glows. The dust darkens. The stars continue their long, quiet motions. There is no need to hold each detail tightly. Just let the thought of the Milky Way remain nearby, like a pale road seen under moonlight. And as we continue, We might linger a little longer on the way astronomers came to know this road from the inside, and on the subtle features that make the galaxy more than just a spiral sketch. There are bars, rings, dust lanes, star-forming complexes, stellar streams, and the large invisible halo that surrounds it all. There are also ordinary stars, countless and steady, each one carrying its own small story of birth, motion, and eventual change. When seen together, they create the impression of a design both grand and patient. The barred center, in particular, is a useful reminder that galaxies can have shapes with structure inside structure. The bar may help move gas toward the inner regions. It may influence how the spiral arms connect. It gives the central area a sense of geometry that is not immediately obvious from the night sky. On maps, it appears as a bright, elongated core. In real observation, it is wrapped in layers of light and dust. Its presence becomes clearer when different wavelengths are combined, when infrared surveys and star counts fill in what the eye cannot see. The center of the Milky Way is also a place of energetic activity, though that energy is still governed by the slow rule of gravity. Stars move quickly there. Gas clouds interact. Magnetic fields thread through the region. Supernova remnants add complexity. The supermassive black hole sits at the middle, not as a single dominating presence in the way fiction sometimes imagines, but as a massive gravitational object whose influence is measurable and real. Surrounding it is a dense nuclear star cluster. The environment is crowded, bright, and intricate. This is where the galaxy feels most like a deep structure rather than a simple pattern. Farther out, the spiral arms can be considered as roots of higher density. The Orion region, where we reside, is often described as a spur or local feature. Its exact classification has been discussed and refined over time, which itself is a pleasant reminder that even maps can be conversational. Astronomers disagree, revise, and improve. Some structures are named with confidence only because they have survived repeated observation. Others remain provisional, useful enough to guide study while still leaving room for future correction. That modesty is part of the beauty. The Milky Way is also wrapped in a halo of older matter. The halo is not as bright as the disk, and its stars are more spread out, but it matters enormously to the galaxy's story. It contains some of the oldest stars we know. It hosts globular clusters, some of which are relics from early epochs. It also contains evidence of galactic cannibalism, if one can use so vivid a word for a process that takes billions of years. Smaller galaxies have been drawn in, stretched, and absorbed. Their stars now move as streams and substructures in the larger halo. In that sense, the Milky Way is both a home and an archive. It keeps what it has gathered. The chemical composition of stars can tell us something about their age and origin. Older stars often have fewer heavy elements because the universe began with mostly hydrogen and helium, and later generations of stars created and dispersed heavier elements through fusion and explosive deaths. By reading that chemistry, astronomers can identify populations that formed early and populations that formed after many cycles of enrichment. The galaxy is therefore not only shaped in space but in time. Its elements bear memory. Carbon in your body, iron in your blood, calcium in your bones, oxygen in the air you breathe, all of it was once inside stars. That idea is familiar enough to have become almost poetic through repetition, but it remains true in a literal and quiet way. The Milky Way's hidden shape is not just an external form. It is part of the long chain of material history that eventually made you, and the room you are in, and the devices that can listen to the galaxy. Everything connects, though not all at once, and not in ways we can fully chart. When you look at a bright night sky, you are seeing a small portion of a much larger arrangement. Even the nearest dense patch of stars is only one segment in a disk that stretches across tens of thousands of light years. The distances become so large that ordinary intuition grows soft around the edges. So astronomers use models, simulations, and careful observation to translate those distances into something the mind can hold. They build three-dimensional maps from many separate measurements, just as a patient listener gathers a story from fragments. Some of the most elegant maps of the Milky Way come from space-based observatories that measure stellar positions with exquisite precision. These surveys have refined our understanding of the local spiral structure, revealing subtle motions and distributions that earlier generations could only guess at. The galaxy is no longer just a vague, luminous band. It has depth, texture, and emotion that can be tracked. But even the best map is still a map. It never replaces the thing itself, and the thing itself is always larger than the drawing. That may be the final and softest lesson of this topic. The Milky Way is hidden not because it is beyond reach, but because being inside it changes how it can be known. We see one layer and infer another. We follow one wavelength and discover another. We notice one star and then ask what surrounds it. We learn to be content with partial light. There is a kind of peace in that practice. Not every shape needs to be seen all at once to be understood. Some things are known by orbit, by repetition, by the way they reveal themselves slowly over time. The galaxy is one of those things. It is not a single picture. It is an accumulated sense of place. A vast turning home with a center we cannot plainly see, arms that are partly obscured, and a halo that fades into the dark. So if your thoughts are beginning to soften now, you can let the galaxy do what it does best, which is continue quietly. The stars remain where they are, though they move. The dust drifts, the gas gathers, the center holds, the arms curve. The hidden shape persists beyond the edge of what can be seen in a single glance. And the night, too, continues with its own patient rhythm. From a window, from a porch, from a train seat, from a bed with the curtains slightly open, the sky can still offer that pale band of light. Sometimes it is washed out by city glow, and sometimes it appears only as a suggestion. But even then the galaxy is still there, surrounding the little world below. It has not gone anywhere. It is simply waiting in the dark, enormous and calm. You do not need to hold the entire Milky Way in mind. Just a part of it is enough. A curve of light, a dark lane, a center unseen, a spiral inferred from the motions of stars, a home vast enough to contain questions and patient enough to allow them. And so, as this long quiet look at our galaxy begins to soften into stillness, let your attention rest on the idea that the universe often reveals itself most clearly through patience. The hidden shape becomes visible not through force, but through listening, comparing, returning, and looking again. The Milky Way will remain above us and around us and within the history of everything we know. Its spiral arms will continue their slow turning. Its dust will continue to veil and to frame. Its center will keep its dense, bright company. Its halo will hold its ancient stars. And somewhere inside all of that, on a quiet orbit among many, the small world you know will keep turning too. You can let that be enough for tonight. Let the stars become softer. Let the dark lanes blur. Let the hidden shape stay near while the room grows more still. And as the galaxy turns on, patient and unhurried, you may simply rest and drift and listen to the long, calm distance between one light and the next. There is another gentle way to think about the Milky Way, and it begins with an old instinct that people have carried for as long as they have looked upward. Before the galaxy was known as a collection of stars arranged in a barred spiral, before it was measured in parsecs and traced with radio telescopes, it was first a feature of wonder. It was a bright river in the night. It was a band of spilled milk, a pathway for the soul, a ladder of birds, a road for gods, a wound in the sky depending on where and when one stood beneath it. Human beings have always tried to name what they could not yet fully see. In ancient Greece, one story said the Milky Way was formed from milk from the goddess Hera, splashed across the heavens. In other cultures, it became a celestial river, a heavenly path, or a lane of mist between worlds. In Chinese tradition, a bright river in the sky separated lovers, and the stars on either side became part of a yearly myth of meeting and distance. In many indigenous traditions across the world, the galactic band was not only seen but understood as a living route, a place of passage, a seasonal marker, a map of meaning. These stories were not measurements, of course, but they were also not mistakes. They were early ways of holding the same mystery. The shape of the Milky Way was hidden from us in part because it was always too close, too surrounding, too much a part of the frame. To see a whole face, one needs distance. To see a whole forest, one needs height. To see a whole galaxy, one would need to stand beyond it, and that is not a place human beings can yet stand. So we learned by patient inference. We learned from positions and motions, from colors and distances, from dust and radio waves, from patterns that emerged slowly as science refined its own vision. That long process has something almost monastic in it. It asks for restraint. It asks for care. It asks us to accept that a truth can be present before it is fully visible. The earliest astronomers had no way to know that the pale river overhead was the combined glow of countless stars. To the naked eye, the band remained a soft stain of light. Even with telescopes, the dust lanes and arm structure were not immediately obvious. For a long time, the galaxy looked less like a barred spiral and more like a flat disk with a bright center obscured by haze, which in a sense is exactly what it is from our position. We live inside the haze and must reason outward. That effort changed astronomy in quiet stages. One of the earliest and most important insights came from simply noticing that the Milky Way is brighter in some directions than others, and that the brighter regions and darker gaps are not random. Dark patches are not empty places. They are clouds of cold gas and dust, small in cosmic terms but large enough to veil the starlight behind them. These clouds are part of the galaxy's life. They are where stars are born. They are the dim, compressed seeds of future suns. So even the darkness has a role. A dust lane is not only an absence. It is a boundary, a nursery, a filter, a silhouette. It can hide and reveal at once. If you look at photographs of spiral galaxies from outside, those dark lanes often trace the graceful curves of the arms like ink brushing across pale light. In our own galaxy, they are harder to make out because we are immersed in them, but they are there, stitching parts of the disk into regions of concealment and brightness. The hidden shape of the Milky Way is partly written in shadow. This is one reason the subject feels so suitable for a quiet hour. There is a tenderness in realizing that much of what we know about our home galaxy came from things we could not directly see. The invisible became legible through its effects. Astronomers traced hydrogen gas by its radio emission, especially the famous 21-centimeter line, which can pass through much of the dust that blocks visible light. That line became a kind of whisper from the galaxy's structure, allowing maps to be drawn in places where ordinary starlight could not help. It was as if the Milky Way had been carrying a secret in its own breath. Later, infrared observations opened another door. Dust that hides visible light glows softly in infrared wavelengths, and stars embedded within dusty regions can be studied more clearly. Where the eye sees only a veil, the infrared sees through it with a kind of patient warmth. Then came surveys of stellar motion, measuring tiny shifts in position and velocity over time. The galaxy began to seem less like a flat picture and more like a living arrangement of currents. A spiral galaxy is not a static ornament. It is a pattern in motion. The arms are not rigid spokes. They are more like regions of density, places where material gathers and passes through, where gas compresses, where new stars emerge, where the disk keeps turning with an almost meditative persistence. The Milky Way's hidden shape includes not only geometry but time. It is a shape that exists because matter moves through it. That can be difficult to imagine, so it helps to think of a crowd moving through a softly lit station at night. The people are not fixed in the bright corridor, yet the corridor itself seems to hold a pattern of arrivals and departures. In the same way, the galaxy's spiral structure is maintained by grand gravitational arrangements, even as individual stars follow their own paths. The sun does not sit still inside a spiral arm like a bead on a string. It orbits the center, and the disk around it is in ongoing motion, a long, slow dance measured in millions of years. Our own sun is not near the center of the Milky Way. It resides out in the disk in one of the quieter neighborhoods, often described as being within or near the Orion Arm, a smaller spiral feature or spur between larger arms. That location is not glamorous, but it is fortunate in a practical sense. The local environment is relatively calm. There is not a dense cluster of massive stars nearby, and there is enough stability for planetary systems to persist. The Earth, then, inhabits a part of the galaxy that seems, by cosmic standards, almost restful. Even that word restful carries a little wonder, because the galaxy is so vast, near and far become difficult ideas. A star is near if it is tens of light years away. A dust cloud is close if it is only a few hundred light years away. The center is approximately 26,000 light years distant, which is so far that the light leaving there when early human civilizations were flourishing is only now arriving in our telescopes. To speak of distance in the Milky Way is to speak of time folded into space. And the center itself has a story. For centuries it was hidden behind dust, visible only indirectly. Then observations in radio, infrared and X-ray wavelengths revealed a crowded, energetic region with a supermassive black hole at its core, now known as Sagittarius A. Around it lies a dense, restless environment of stars, gas, magnetic fields, and strong gravitational forces. It is not a calm heart in the ordinary sense. It is a powerful, active, and deeply obscured place. Yet even there, on scales of human imagination, the motions are measured and the fury is bounded by law. The center holds its mysteries in a disciplined way. Some ancient mythologies imagined a sacred center from which the world radiated outward. In a poetic sense, the galactic center can feel similar, though the truth is more technical and less anthropomorphic. It is a gravitational anchor, a place where mass accumulates and around which the rest of the disk turns. The idea of a center that cannot be seen directly but shapes everything around it is a very old one. We carry such ideas in temples, in burial mounds, in stories of lost capitals, in maps of underworlds, in the quiet chambers of memory. The Milky Way has its own underworld of sorts. Behind the bright fields of stars are the dark lanes. Beneath the visible disk lie motions traced by gas clouds and stellar streams. Beyond the main body stretches the halo, a much more diffuse region containing ancient stars, globular clusters, and remnants of earlier galactic events. The halo is like a memory surrounding a body. It contains traces of mergers and accretions, evidence that the Milky Way did not grow all at once, but was assembled over long ages from smaller systems that fell in and were absorbed. This is one of the quieter revelations of modern astronomy. Our galaxy has a history of gathering. It has eaten smaller galaxies, or at least merged with them, over billions of years. Some stars in the halo may once have belonged to separate systems with their own skies, their own planets, perhaps their own silent nights. The Milky Way is not merely a home, it is also a record of encounters. There is something almost archaeological in that thought. Astronomers can read the debris of old mergers by studying stellar motions and chemical abundances. Stars carry signatures of their birthplaces in the elements they contain. A star rich in heavy elements tells a different formation story from one that formed early, before many generations of supernovae enriched the galactic gas. These chemical fingerprints help reconstruct ancient episodes of building and disruption. In that sense, the galaxy remembers through matter. The oldest stars in the halo are among the most precious witnesses we have. They are not ancient in the mythical sense, but in the true physical sense of having formed in the early universe, soon after the first generations of stars seeded the cosmos with heavier elements. Around them, the Milky Way's hidden shape becomes a palimpsest of epochs. The disk, the bulge, the halo, the bar, the arms, the streams, all overlapping in time and geometry. It is less like a simple diagram and more like a long city built over old foundations, where the newest streets cross much older roads. In a way, the galaxy is full of ruins, not stone ruins but dynamical ones. Tidal streams stretch across the halo like faint handwriting left by disrupted clusters and dwarf galaxies. Some streams are still being mapped. They trail around the galaxy in graceful arcs, thin and ghostly, barely visible against the star field. These are the remains of systems that the Milky Way has taken into itself over immense spans of time. They are reminders that even galaxies are not isolated. They grow by contact, by capture, by slow exchange. There is a legend-like quality to these faint streams. They are hard to see, easy to overlook, and yet they carry history. They are the galaxy's equivalent of lost roads or submerged riverbeds. They tell us where something once moved, even if the original body is gone. The same is true of some of the galaxy's larger mysteries, such as its exact mass and outer boundary. How much of the Milky Way is truly bound to it? Where does the visible disk end and the more diffuse halo become indistinct? How large is the dark matter halo that surrounds the luminous components? These are not questions with one immediate answer, because the galaxy's full extent is partly defined by invisible influence. Dark matter, though unseen directly, shapes the motions of stars and gas through gravity. It is one of the deepest quiet facts of modern cosmology that most of the mass in the universe does not shine. That reality can feel almost like a myth from an older age, a hidden foundation under the visible world. But this is not a tale told for ornament. It is inferred from evidence, from rotation curves, from galaxy clusters, from gravitational lensing, from the behavior of large-scale structure. The Milky Way spins as if held together by more mass than can be accounted for by stars, dust, and gas alone. The unseen scaffolding is part of the shape. And so the hidden shape of the Milky Way is not just its spiral arms or its dust lanes. It is also the invisible framework that grants coherence to the whole. Even in ancient sky lore, there was often a sense that the visible heavens rested upon unseen supports. The sky was sometimes imagined as a dome, a river, a roof, a veil. Within those frameworks, brightness and darkness had their places. Today our model is different, but the emotional intuition remains strangely familiar. We know that what we see is only the surface of what is there. We know there are layers. The science of the Milky Way has also depended on careful revision. The first sketches of the galaxy's structure were incomplete and sometimes incorrect. Astronomers once imagined the Sun closer to the center than it is, or treated the galaxy as simpler and smaller than later evidence allowed. As measurement improved, the map became more detailed but also more complex. This is often how knowledge grows, not in a straight line but by gentle corrections. A wrong edge becomes a better one. A blurred arm becomes a traced one. A guess becomes a coordinate. Sometimes the most elegant part of that process is the humility it requires. To make a galaxy map from within a galaxy is an act of self-location. It asks, in a sense, where am I within the whole? That is not only an astronomical question, it is also a quiet human question. We ask versions of it in memory, in history, in family, in place. The Milky Way becomes a mirror of this larger habit of thought. We are inside something vast, and yet we keep trying to chart it honestly. The solar neighborhood itself has its own modest story. Nearby stars move with one another, and yet not together, each tracing an orbit shaped by the galaxy's mass distribution and local perturbations. Open clusters drift apart over time. Molecular clouds gather and then disperse. Supernovae enrich the surrounding medium. The interstellar medium is never truly still. It is a thin, delicate mixture of gas, dust, radiation, and fields, and it serves as both residue and beginning. In it, the old returns as the new. A star forms, shines, ages, and eventually returns material to the galaxy. The materials of life on Earth were forged in previous generations of stars. Carbon, oxygen, nitrogen, iron, all of it arrived through cosmic recycling. In this sense, the Milky Way's hidden shape is also a hidden continuity. The galaxy is made of time layered into substance. What seems separate is often connected by long, patient inheritance. That inheritance extends to the night sky itself, The light from the galaxy does not come all at once. Some of it is ancient by the time it reaches us. Some stars we see with our naked eyes may no longer exist as they appear to us, though on the scale of galactic time the difference is small. When we look into the Milky Way, we are looking into a living past. The sky is not only above, it is also behind us in time. It can be calming to dwell on that gently without needing to solve it. The Milky Way has also been a subject of many maps made from Earth's surface, and some of the best known came from careful surveys of neutral hydrogen. Because hydrogen is so abundant, and because it emits at radio wavelengths that can travel through dusty regions, it became one of the main tracers of galactic arms. Scientists use the Doppler shift of that emission to estimate motion toward or away from us. By combining these measurements with models of rotation, they began to infer where the spiral features lay. This method, while powerful, is complicated by the fact that we are inside the rotating disk. Distances are not easy to infer from motion alone, especially when objects at different places can share similar velocities along a line of sight. So astronomers built the map piece by piece, using parallax from nearby stars, standard candles like Cepheid variables, masers in star-forming regions, and other carefully calibrated indicators. Each technique illuminated a different part of the structure, like small lamps placed in a long corridor. The result is a galaxy we know more clearly than ever, and yet still not completely. There are still questions about the precise number and extent of the spiral arms. There are uncertainties about the strength and role of the central bar. There are debates about the warp and flare of the outer disk, where the galaxy bends and thickens in ways that may reflect past interactions or ongoing gravitational influences. Even the disk itself is not perfectly flat. It is gently warped like a thin sheet slightly disturbed by a hidden hand. The outer regions may ripple and tilt. This too is interesting in a bedtime sort of way. The galaxy is not mechanically perfect. It is shaped by history. It bears the marks of old encounters, internal dynamics, and the slow pull of the unseen. A rough edge can be more truthful than a neat one. One of the most lovely things about galactic astronomy is how often scale changes the meaning of a word. A cloud in the sky can be a metaphor, but in the Milky Way it can also be a molecular nursery. A lane of darkness can feel empty, but in fact it may be dense with material. A halo can suggest light and decoration, but in astronomy it can be a vast reservoir of ancient debris. A spiral can feel decorative, but in the galaxy it is a consequence of gravity, density waves, and rotation. And a hidden shape is not absent. It is only awaiting the right kind of seeing. The right kind of seeing has taken many forms across history. Ancient observers tracked the seasonal appearance of the galactic band in relation to weather, migration, planting, and ceremonial calendars. In places where the sky was dark and clear, the Milky Way could serve as a seasonal clock. Its orientation changed through the year, and its visibility altered with latitude and climate. People learned its habits as one learns the habits of a river, a bird, or a familiar wind. Long before radio maps, there were sky stories that preserved orientation and memory. In some traditions, the Milky Way marked the route of ancestral beings, or the road taken by souls, or the place where the world's order had first been set. These stories did not seek to reduce the sky to mechanism. They sought to live within its meaning. There is a gentleness in that, a recognition that wonder itself can be a form of knowledge. The Milky Way remains a source of wonder because it is both ordinary and impossible. It is ordinary in the sense that it is our home system, one galaxy among many. It is impossible in the sense that no one can step back far enough to look at it whole from outside. We rely on models, on surveys, on indirect measurements, on analogies drawn from other galaxies visible across space. We are like residents of a city trying to reconstruct its shape using street sounds, reflections in windows, and the routes of familiar buses. Yet the reconstruction is not guesswork in the careless sense. It is disciplined, cumulative, and beautifully patient. The fact that we can infer a barred spiral structure from within the disk is itself remarkable. The bar at the center, a luminous, elongated feature of stars, seems to play a significant role in redistributing material and perhaps in guiding the spiral pattern. Bars are common in disk galaxies, and the Milky Way appears to have one, though its precise size and orientation have been refined over time. This central bar may help channel gas inward, influence star formation, and shape the dynamics of the inner galaxy. It is a structural note in the larger composition. Farther out, the spiral arms are sites of ongoing creation. Massive stars form there and live briefly, shining intensely before ending in supernova explosions that enrich the surroundings and send shock waves through the interstellar medium. The arms are thus places of beginning and ending together. In them, the galaxy continues to write itself. The luminous blue stars are relatively young, while the older, cooler stars trace a more settled history. The result is a layered portrait of age. Age in the galaxy is not like age in a person. A star can be young at 100 million years and old at 10 billion. A cluster can disperse, while its members continue on separate paths. A spiral arm can persist as a pattern, while the material inside it changes completely. Time in the Milky Way is a scale of transformation rather than permanence. Even the center, seemingly the most stable anchor, hosts stars on complex orbits and episodes of activity that rise and quiet over immense spans. There is a kind of quiet drama in that. The galaxy has also helped humans measure their own place in the universe. When Edwin Hubble and others showed that some nebulae were external galaxies, the Milky Way changed from being the universe to being one island among many. Then our sense of scale deepened again and again. The universe expanded in our imagination as it expanded in our models. The Milky Way became local, not central. And yet local is not a small thing. It is simply where life stands. That realization can make the night feel spacious rather than lonely. The galaxy is near enough to be home and vast enough to remind us that home can be enormous. Even now, the maps continue to improve. New astrometric data sharpen the positions of nearby stars. Large surveys trace stellar populations in 3 dimensions. Variable stars act as distance beacons. Infrared and radio observations continue to uncover features in the obscured inner regions. Some newly identified structures are faint and uncertain, but even uncertainty has a place. It keeps the map open. One especially lovely part of this ongoing work is the way it connects precision with humility. A few millionths of an arcsecond can matter. A small improvement in calibration can shift a model of galactic structure. A tiny correction in distance can alter the inferred placement of a spiral feature, and yet all of it serves a larger tenderness, the effort to understand our surroundings without pretending to stand outside them. The Milky Way is full of regions that defy easy visibility. The galactic center, bright and crowded, is largely hidden in optical light. The far side of the disk is complicated by dust and overlapping structures. The outer halo is diffuse and faint. Even the local neighborhood can be hard to chart in depth because nearby gas and stellar motions overlap along the line of sight. The hidden shape is therefore not one mystery but many, stacked together. Some mysteries are old enough to feel almost ceremonial. The exact origin of the galaxy's spiral arms remains a topic of research. Are they long-lived density waves, transient features, or some mixture of both? How did the bar evolve, and how does it interact with the arms? How much of the disk's current shape was influenced by past mergers, such as interactions with dwarf galaxies that left behind ripples and streams? What is the precise distribution of dark matter, and how smooth or clumpy is the halo? These questions remain open in subtle ways, not because science lacks rigor, but because the galaxy is genuinely intricate. That intricacy is part of its beauty. A simplified picture can be useful, but the real galaxy has wrinkles. It has asymmetries. It has histories that do not fit neatly into a single sentence. It has stellar populations with different ages and motions, gas clouds with different temperatures and chemical compositions, and regions where the warp of the disk shifts the plane up or down. The hidden shape of the Milky Way is therefore not a single hidden form. It is a set of nested forms, each revealing something about the whole. If you imagine standing within a dark planetarium of immense size, with stars gently projected on all sides, you might begin to sense why this topic invites calm rather than urgency. The galaxy does not hurry. Its arms turn over hundreds of millions of years. Its stars live and die on scales too large to be felt in a human hour. Its center remains distant. Its halo drifts. Its dust settles and stirs and settles again. All of this can be held lightly, like a thought that does not need to be solved tonight. Somewhere in the outer disk, regions of star formation may be quietly active, as they have been for eons. In the interstellar clouds, molecules like carbon monoxide trace cold, dense pockets where new systems may eventually form. In the hot gas between stars, supernova remnants expand and fade. Pulsars spin with regularity. Open clusters dissolve. The galaxy replenishes itself through continual circulation. It is less a thing than a process, and yet the word Milky Way still carries a softness that suits bedtime. It is a human name for a cosmic system, but it also sounds like a trail of milk, a path of pale light, a thing just barely visible in the dark. The name preserves the older feeling of the sky, when the galaxy was a luminous band before it was a measured structure. There is something charming about that continuity. Our language keeps a trace of our earliest wonder, even as our instruments grow more precise. The oldest stargazers could not know about the central black hole, the bar, the halo, or the faint streams from vanished companions, but they knew the sky required patience. They knew the stars returned in patterns. They knew the dark season changed the sky's appearance, and that the luminous band overhead could orient a story or a journey. In that sense, our modern maps are not a replacement for old wonder. They are its extension. The same galactic band that inspired myth now inspires data. Both are ways of staying with the question, and perhaps that is the deepest hidden shape of all, not only the spiral form of the Milky Way, but the shape of human attention as it moves toward it. We begin with a glance. We follow a faint band. We notice a dark lane. We infer depth. We learn that the center is obscured. We accept that the whole cannot be seen from within. We revise the map and then revise it again. The process itself becomes a quiet kind of devotion. In the end, the Milky Way does not need to be fully contained in thought to be beloved. A partial understanding can be enough to deepen the feeling of place. A few accurate facts can coexist with mystery. The galaxy can remain vast and hidden and partially known while still feeling near, so let the mind grow gentle around it. Imagine the disk turning slowly, with dust lanes like thin shadows across soft light. Imagine the bar at the center, bright and elongated, quietly shaping the flow of material. Imagine spiral arms where new stars are being born, far away and long ago at once. Imagine the halo as a faint memory surrounding the whole, carrying old stars and lost streams. Imagine the dark matter halo as an unseen frame, holding the system together in ways we are still learning to describe. And then imagine not needing to hold any of it very tightly. The galaxy can remain patient and immense while your thoughts settle into their own smaller orbit. The ancient stories can rest beside the modern maps. The myths of milk, of rivers, of roads, of lovers separated by a celestial stream can sit quietly next to radio emission and infrared surveys. The old and the new need not cancel each other. They can accompany one another in the long night. There is comfort in that companionship. The Milky Way has been seen by countless eyes across time, from deserts and shorelines, high plateaus and forest clearings, ship decks and mountain camps, temple courtyards and city rooftops. Each observer saw only a portion of the same band, yet each glimpse belonged to the larger whole. That is how knowledge often works. No single gaze owns the sky. The sky is gathered slowly by many moments of attention. And tonight, your own attention can be one more quiet moment added to that long human noticing. The stars do not ask for anything. They shine or they do not. Dust obscures and reveals. The center remains bright behind its veil. The arms continue their turning. The halo drifts. The hidden shape persists. You can let the thought become softer and softer now, until it is almost only a feeling of being held within something large and kind. The galaxy is not looking back, but it is surrounding you in the most literal sense. Every breath, every wall, every sleeping house, every old road and silent tree is part of the same great system of stars and gas and gravity. There is no need to reach farther tonight. Only rest. Only drift with the understanding that the Milky Way has many layers, many histories, many unseen structures, and that all of them continue calmly beyond the edge of immediate sight. Its shape is hidden but not lost. Its stories are ancient but not finished. Its light is dim in places, bright in others, and always moving through the dark. And so the night can close around that truth gently. The galaxy turns, the dust goes on, the hidden shape remains, and you for now may simply sleep beneath it, carried by the quiet fact that you live inside a vast, luminous home whose full outline is still being learned, one patient observation at a time. The oldest skywatchers did not need diagrams to feel that the heavens were layered with meaning. They simply looked upward and noticed that the same bright river crossed the dark season after season, never quite the same, yet always returning. Before telescopes and spectroscopy, before radio maps and orbital surveys, there was only the patient human act of looking. And in that looking, there was already the beginning of astronomy. To imagine the Milky Way's hidden shape is to imagine the long road by which people learned that a luminous band could be something more than decoration. It is to stand beside old observers who might have called it a river of spirits, a trail of spilled grain, a path left by a celestial animal, a seam in the fabric of night. Different cultures gave it different names, but the feeling was often similar. This was not ordinary darkness. This was not just the background. It was a presence. It was a sign that the sky had depth. The Greeks told stories that tied the pale band to milk, to divine struggle, to the accident of gods and mortals. In one version, milk spilled across the sky when the goddess Hera pushed the infant Heracles away, and the bright stain remained. In other traditions, the heavenly road became a route for souls or a border between realms. The Sanskrit traditions spoke of celestial rivers and stars as lamps. In China, the Milky Way was a silver river separating the weaver girl and the cowherd, a story of distance, longing, and the annual crossing of a bridge made by birds. In the Andes, people read not only the bright stars but the dark spaces between them, seeing figures in the dust lanes themselves. That is a beautiful reversal, and perhaps one of the most accurate intuitions of all. The sky is shaped not only by light, but also by shadow. Long before modern maps revealed the barred spiral structure, the Milky Way already carried that double nature. It was both obvious and hidden. Anyone could see it. No one could fully name it. That is one of the gentle ironies of science. The most familiar things can remain the least understood for the longest time. The moon was once a mystery too. So was the shape of the Earth, the cause of tides, the distance to the stars. The Milky Way belonged to that same lineage of familiar enigmas. When Galileo turned his telescope toward the band of light, he found that the milkiness dissolved into countless stars. That observation changed the feeling of the sky forever. What had seemed like a painted stripe became a crowd, a field of points too distant or too faint to be individually known without aid. It was a small revelation in one sense and a vast one in another. The sky did not become less wondrous when it became more specific. It became stranger, more populated, more alive with depth. And still, even after the band was resolved into stars, the full shape remained elusive. The telescope could break the luminous mist into pieces, but the whole system still refused to lie flat before the human eye. We were inside it after all. That mattered. There is a kind of map one cannot draw while standing on the land it depicts. One may trace roads and rivers, but the broad outline of a country is easier to see from above. Our ancestors on Earth had to become cartographers of a city they could never rise entirely beyond. They had to infer the Milky Way from within the Milky Way. That is a quietly difficult task. It is not unlike trying to understand the structure of a forest while standing under the canopy of one tree. The trunk is immediate, the leaves are near, the horizon is hidden. Yet by patient observation, by measuring motions and distances, by comparing wavelengths of light, by watching how dust dims some stars and leaves others bright, a larger pattern slowly emerges. The galaxy becomes less like a painted ceiling and more like an ecosystem with arms, lanes, currents, and regions of birth and aging. The words themselves are soothing if you let them be. Disk, bar, spiral arm, bulge, halo. Each name is a small lantern hanging in the dark. The disk is a flattened plane where most of the stars, gas, and dust live, and where the Milky Way's spiral structure can be traced. The central bar is an elongated feature, a bright and mass-rich region that helps guide the motion of the galaxy's inner material. The bulge is the dense swelling around the center, where old stars gather in a crowded glow. The halo is more diffuse, stretching beyond the disk, holding ancient stars, globular clusters, and traces of the galaxy's earliest formation. Around all of it perhaps lies the dark matter halo, invisible yet influential, inferred from the way stars and gas move. These are not dramatic words, but they are comforting in their precision. They describe a living arrangement of matter and gravity that has persisted for billions of years. To speak them softly is to remember that the universe is not only noise and explosion. It is also pattern, equilibrium, and long accommodation. The Milky Way's hidden shape became clearer only because astronomers learned to see in more than visible light. Dust, which so beautifully creates the dark lanes we see from Earth, also hides the center from ordinary view. But infrared light can pass through much of that veil. Radio waves can travel through regions opaque to optical telescopes. Different instruments are like different kinds of attention. Some notice what others miss. Some are more patient with obscurity. This too has an almost human resemblance. We understand one another and the world not by one perfect faculty but by many partial ones. Sight is useful, so is memory, so is patience, so is listening. The galaxy taught astronomy to become multicolored in its methods because the sky itself did not offer all its truth in one visible line. And even now the hidden shape is still being refined. Scientists continue to debate the exact number and placement of the Milky Way's major spiral arms. They compare observations of hydrogen gas, young star clusters, masers, and dust features. They sort through distance estimates, rotation curves, and the complicated effects of our position within the disk. The map does not settle into finality. It becomes better, then slightly better again. A shape once guessed at now appears with more edges, more curves, more subtlety. Yet the more exact the picture becomes, the more one can sense how much remains provisional. There is a deep comfort in provisional knowledge. It means the truth is still being approached, still cared for, still alive in the minds of those who seek it. A finished mystery can feel dead. An ongoing mystery can feel like a room with a lamp left on. The Milky Way has always been a room with the lamp left on. There are ancient star maps that try in their own way to make sense of this room. On clay tablets on parchment, carved into stone or painted on temple walls, people recorded the heavens as they saw them. They named bright stars and seasonal risings. They associated celestial motions with kingship, agriculture, fate, and divine order. The sky became an archive. Some of those records were practical for calendars and harvests. Some were ceremonial for ritual and memory. Some were simply acts of wonder preserved in form. And the Milky Way, even when not singled out by modern scientific language, was part of that archive of wonder. It would have been visible above ziggurats, above Egyptian riverbanks, above the homes of early Chinese astronomers, above the megalithic sites of Europe, above the firelit camps of people whose names are no longer known but whose eyes were as human as ours. Every generation inherited the same sky, though never exactly the same one. The Earth turns, the seasons shift, dust, air, weather, and moonlight alter the view, yet the band remains patient and recurrent. If you were to stand beneath it far from city light, the sense of scale might be nearly enough to quiet the mind all by itself. The sky becomes not an emptiness but a thickness. The stars are not pasted on a sheet, they are distributed through distance. The dark regions are not absence, they are structure. Even the spaces between the stars begin to feel meaningful. In a city, the sky can seem flat because the human world is brighter. In the open dark, the sky gains its own architecture. This is one reason the Milky Way has always inspired myth. We are pattern-seeking creatures. When faced with a luminous band across darkness, we do what the mind has always done. We make a story. Stories do not necessarily replace truth. Sometimes they are the first shape truth takes in language. A myth can preserve a sense of scale before it can preserve a number. It can hold awe before it can hold data. The hidden shape of the galaxy, then, was once hidden in a moral and poetic sense as well as a physical one. People knew that it meant something, even before they knew what it was made of. And because the galaxy is so immense, the feeling of meaning was not misplaced. The actual structure is no less extraordinary than the myths. A barred spiral galaxy is already strange enough to deserve poetry. A disk of stars tens of thousands of light-years across, rotating around a center that contains a supermassive black hole, laced with gas clouds where suns are born and star streams where ancient systems have been torn apart, is not less marvelous because it can be measured. If anything, measurement gives the wonder a steadier seat. The center of our galaxy deserves its own quiet attention. There, hidden behind veils of dust, lies Sagittarius A, the supermassive black hole around which the inner stars orbit. Its presence is inferred through motion, through the rapid dance of stars in the crowded core. The black hole itself is not a devouring mouth in the cinematic sense so often imagined, but a region where gravity becomes intense in a compact way, where matter follows paths shaped by profound curvature. It is invisible to the eye, yet central to the story. That idea alone feels almost mythic, a hidden ruler at the heart of a city of stars, an unseen weight around which everything turns. Ancient myths often placed a king or god at the center of cosmic order. The modern universe sometimes does not offer a person there, but it still offers a center of influence. The black hole is not a throne, but it is a pivot. It is not a deity, but it has the effect of a deep gravitational hush. Even the phrasing can be calming if you let it be. Stars orbit, matter flows, the core remains concealed. The galactic bar, too, has a kind of understated elegance. It is not a straight road in the human sense, but an elongated concentration of stars that helps redistribute matter inward. Bars are common in spiral galaxies, as if structure itself likes to gather into these bright linear forms before curving outward into arms. In the Milky Way, the bar is inferred from star counts, gas dynamics, and infrared observations. It seems to orient the inner spiral arms and possibly influence how material moves toward the center. A bar is a modest object in a room, but in a galaxy it can quietly shape the whole pattern. Such is often the way with unseen influences. A small bias in motion, a slow drift in mass, a hidden distribution of matter, and the vast architecture of a system takes form. The universe does not always announce its structures loudly. Sometimes it reveals them through a slight difference in brightness, a subtle wobble in velocity, a faint dimming along a line of sight. This is why astronomy is sometimes so beautifully patient. It rewards watching over long intervals. A single night provides only fragments. A decade begins to show motion. A century can alter the map. In the case of galaxies, the timescales are so large that human lives feel like brief notes held against an enormous sustained chord. Yet that brevity does not diminish the act of knowing. It gives it tenderness. The Milky Way has been slowly mapped by many kinds of patience. Star catalogues from the past helped establish positions. Later, Photographic plates captured more light than the eye could hold. Then came space-based observatories that removed atmospheric blur and measured positions with astonishing exactness. The Gaia mission, in particular, has transformed the field by charting the motions and distances of more than 1 billion stars, allowing astronomers to reconstruct parts of the galaxy's structure and history with unprecedented clarity. There is something quietly beautiful about a machine in space quietly counting stars while the Earth turns below it. That counting, though, is not only numerical, it is interpretive. From motions one infers structure, from structure one infers history. From history one infers the slow assembling of the galaxy from smaller pieces. The Milky Way did not simply appear in its present form. It grew, it accreted, it merged. It absorbed smaller galaxies, long ago, in episodes that still leave signatures in the motions and compositions of stars. Some of those ancient encounters are remembered in streams of stars that arc through the halo like faint handwriting. There is something haunting about star streams. They are the remains of systems stretched thin by gravity, the lingering traces of once coherent companions. A dwarf galaxy may have come close, be torn apart over millions or billions of years, and leave behind a trail of stars that preserves its passage. What was once a small galaxy becomes a ribbon. What was once a kingdom becomes a whisper. Yet the whisper endures long enough to be read. This is one of the hidden biographies of the Milky Way. It is not only a spiral but a collector of histories. Every star cluster, every stream, every patch of unusual composition is a clue to an earlier chapter. The galaxy is ancient enough to have a layered memory. Its outer regions are not empty margins, they are archives. Some of the oldest stars may have formed when the universe was still young, carrying chemical signatures of the first generations of stellar life. Some globular clusters orbit in the halo like old companions, dense and luminous, perhaps among the earliest bound systems to survive the galaxy's assembly. To think of the halo in this way is to think of it as a rim of memory, not bright in the everyday sense but essential. The halo holds the oldest witnesses. It holds evidence of the early universe, of mergers and accretion, of the long, slow building of form. It is faint because its contents are spread thin across vast space, but faintness is not insignificance. Many of the universe's most important facts are quiet. The dark matter halo, meanwhile, remains one of the most profound quiet facts of all. We do not see it directly. We see the consequences of its presence in rotation curves and in the way galaxies remain bound. It seems to provide the mass that ordinary matter cannot account for. Its nature remains unknown. Particles are proposed. Explanations are tested. Experiments continue. The mystery is not a failure of science. It is a frontier with a patient boundary. There is a particular serenity in mysteries that have not yet been forced into premature closure. They can be lived with gently. They can be studied without panic. The dark matter halo is a reminder that the universe is not obliged to be fully transparent to us, and yet it remains legible enough to let us know something is there. This balance between concealment and inference is one of the deepest patterns in astronomy. We see by effects, we know by consequence. The invisible is not absent, it is merely indirect. In older mythic languages, unseen forces were often personified. In modern science, they are described by equations and models, but the feeling of standing before something larger than direct sight has not changed much. The mind still pauses. The mind still wonders what structure lies behind the shimmer. The Milky Way, with its own hidden form, teaches that same lesson at scales both practical and existential. What you can see is only part of what is there. The dust lanes are perhaps the most immediately visible metaphor for that truth. On a clear, dark night, the Milky Way can show darker rifts across its luminous band. These are not holes in the sky, but clouds of interstellar dust and gas, absorbing light and marking the places where matter gathers. From the standpoint of human perception, darkness appears here as structure rather than absence. That is a remarkable inversion. We are accustomed to thinking of darkness as emptiness, but in the galaxy, darkness can be an active participant in the map. The Great Dark Rift, visible to the naked eye in some parts of the sky, helped generations of observers understand that the band was not uniform. Ancient peoples may have assigned symbolic meaning to those dark divisions as well. The sky, after all, was always full of thresholds. A dark lane could suggest a riverbank, a road, a separation between worlds, or simply a path of obscuration where some celestial substance had gathered. Even without the physics, the intuition was strong. Where the light is interrupted, there is a reason. And then there are the star-forming regions, those soft nurseries in the spiral arms where gas collapses, heats, and eventually ignites into new suns. These regions are among the galaxy's quietest miracles. They are often hidden behind dust, observed in infrared and radio, glowing in emissions that reveal the presence of molecular clouds and young stars. A place where the future is taking shape is not always loud. Sometimes it is a dark cloud with a warm interior, a place where gravity is slowly preparing brightness. To dwell on this is to feel how the galaxy contains all ages at once. There are ancient stars in the halo, middle-aged stars in the disk, newborn stars in the arms, and the ever-present possibility of future systems forming from the same circulating reservoirs of gas. The Milky Way is not static. It is a process, a long-duration arrangement, a history with no single page that can be called the whole. Human history, too, is more layered than it first appears. The first people to look up at the Milky Way did so under skies free of electric light. Later observers looked from cities whose lamps began to dull the stars. Today, many people must travel far from urban glow to see the band clearly at all. This means the Milky Way has become, for some, a remembered sky rather than an everyday one. Yet the physical galaxy has not changed its habit of surrounding us. Only our view has altered. There is a melancholy in that, but also a kind of hope. For the sky can be recovered, light pollution can be reduced, the night can become dark again in pockets and regions if people choose. Even now, many places remain where the galaxy spills overhead with astonishing clarity. In those places one may feel as ancient observers did, that one is standing beneath a road of innumerable lanterns, and perhaps that is enough for one night. Perhaps not everything must be resolved to be meaningful. The hidden shape of the Milky Way also reminds us that perspective matters profoundly. Suppose you lived within a forest and had never seen an aerial view. You might know the scent of bark, the path of deer, the seasonal fall of leaves, but not the full pattern of the canopy. Similarly, we live within the galaxy. There is no external perch near enough to give us a picture in one glance. We infer the form through distributed evidence. We take in the positions of stars in many directions. We measure velocities. We chart composition. We listen to radio and infrared and microwave murmurs. We reconstruct. This reconstructive process has an elegance of its own. It mirrors how memory works. A childhood home is not remembered in one image but in fragments. A hallway, a window, the sound of rain on a roof, the shape of a staircase, the smell of dust warmed by afternoon light. The whole is assembled from partial returns. The Milky Way is known in a similar way, piece by piece, until the pieces suggest a larger dwelling. And what a dwelling it is! A galaxy of perhaps 100 to 400 billion stars, depending on how one counts the faintest contributors. A vast disk spanning about 100,000 light-years or more, with a smaller central bar and bulge, a halo of old stars and globular clusters, clouds of gas and dust, a supermassive black hole in the center, and unseen mass shaping its movements. It is not one object in the simple sense. It is a community of matter, held together by gravity and time. The solar system occupies only a quiet suburb of that community, in one of the spiral arms far from the center. This is sometimes called the Orion Arm or Orion Spur, a modest segment between larger structures. Our neighborhood is not glamorous in cosmic terms. It is useful and safe in its own way, far enough from the galactic center's crowded conditions to allow long stability, perhaps contributing to the delicate conditions under which life can persist. There is something comforting in that thought too. We are not at the center, and that may be a mercy. Ancient cosmologies often placed Earth at the center, but the universe kept teaching humility. We are on a planet, around a star, in an arm, in a disk, in a galaxy, in a local group of galaxies, in a universe still expanding and still partly unknown. Each displacement from imagined centrality has brought with it a more spacious understanding. To lose a false center is not to become lost, it is to become part of a larger order. The Milky Way's hidden shape participates in that lesson. The more we learn, the less the galaxy seems like a flat emblem, and the more it resembles a habitat of motion, layered with histories and currents. And yet the old symbolic meanings are not erased by the new knowledge. They remain as undercurrents. The river of heaven is still a river, even if the water is now understood as stars and gas. The road in the sky is still a road, even if we know it is a disk seen from within. Myth and measurement can rest beside each other like two lamps on a long windowsill. It is worth dwelling gently on how many human cultures aligned the Milky Way with crossing, separation, or passage. Perhaps this is because a bright band through darkness naturally suggests movement. Perhaps also because human life has always been shaped by journeys, migrations, departures, and returns. The sky became a mirror for those experiences. The river of stars might carry souls, or lovers, or the dead, or the dreams of the living. Even where the details differ, the emotional grammar is often similar. The Milky Way is a path across something immense, and if it is a path, then perhaps we are never entirely outside it. We are within the passage. We are moving with the rest of the galaxy, carried around the center at extraordinary speed without feeling the motion directly. The Sun and its planets orbit the center of the Milky Way once every couple of 100 million years, a period so long that the last time our region completed a full circuit, the arrangement of continents, climate, and life was profoundly different. This is another quiet fact that can soften the mind. Motion does not need to be felt to be real. Change does not need to be dramatic to be vast. From this perspective, the galaxy's hidden shape is also the shape of time. The spiral arms are not only places of matter but places of sequence. Stars form, live, die, gas circulates, dust condenses, elements are forged in stellar interiors and distributed by supernovae and stellar winds. Heavier atoms, the ingredients of planets and bones and oceans, are made through those long cycles. In that sense, the galaxy is not merely a setting for life. It is the slow chemical ancestor of life. The carbon in a breath, the calcium in a shell, the iron in blood, the oxygen in water, all of it part of a much older stellar story. That realization need not be grandiose. It can be quiet, almost domestic. A spoon in a kitchen, a window at night, a sleeping town, and beyond the roof, the old ongoing work of stars. The elements are still traveling. The galaxy is still mixing them. The hidden shape supports the hidden exchange. In some ways, the Milky Way has been a teacher of patience to civilization itself. Its study required better instruments, more accurate clocks, larger surveys, and the willingness to accept that first impressions were incomplete. People had to revise the idea that the sun sat near the center of everything. They had to accept that the bright band overhead was not a cloud in the atmosphere, but a distant concentration of stars. They had to learn that the galaxy's light is altered by dust, that our own view is embedded and limited, that even the best maps are provisional. These are not easy lessons for a species that often likes to imagine certainty, but they are enriching lessons. They make room for humility without despair. They place us in an honest relation to scale. The galaxy is too large to own, but not too large to know in part. That is enough for wonder to remain stable. And wonder itself can be a form of rest. If you let the thought soften, the Milky Way becomes less a problem to solve and more a landscape to inhabit. The spiral arms are broad and dim. The bar is a quiet axis. The bulge glows behind its veil. The halo surrounds everything in the old outer light of the galaxy. Dark matter unseen holds the system in its long coherence. Stars turn, dust drifts, gas cools and warms. Ancient mergers have left subtle ripples. Future mergers may one day reshape the whole. Indeed, the galaxy is already in slow interaction with Andromeda, far in the future, though on timescales that make such facts feel almost like geological weather. Even those immense events belong to the patient logic of cosmic history. For now, the galaxy keeps its present shape. And what a fortunate present it is, with a sun stable enough to nurture life, with skies dark enough in many places to still reveal the luminous band, with minds capable of tracing invisible structure from faint evidence. It is a strange and generous arrangement. Perhaps the hidden shape of the Milky Way is not only an astronomical topic, but a meditation on partial knowledge. We do not see the whole, we do see enough. We live inside what we seek to understand. We are not separate from the object of our study. The same elements, the same gravity, the same cosmic history bind observer and observed together. That is why the galaxy can feel intimate even at a distance. It is made of the same universe that made us. Some nights when the sky is clear and the stars are numerous, the Milky Way seems almost like a memory of daylight, but stretched and thinned beyond ordinary color. Other nights it is merely an impression, a soft brightening where the darkness is not wholly empty. Either way, the feeling is enough. The galaxy does not require perfect visibility to be present. Its structure persists regardless of whether we can name each part. That is true of many things worth loving. The old astronomers could not have known about infrared surveys or dark matter halos, but they knew the hush of a sky full of pattern. They knew that the heavens could guide calendars, stories, voyages, and prayers. They knew that the night was not a void, but a vast and ordered country. Their myths were attempts to live within that country before the map was complete. Modern astronomy has refined the map, but not extinguished the country's beauty. A band of stars still hovers over the world, and the human mind still turns toward it with the same quiet curiosity. So let the questions remain gentle. What exactly is the unseen shape of the galaxy from the inside? How do dust lanes carve the light? Which ancient mergers contributed to the halo's faint streams? How does the bar govern the flow of material in the inner regions? What is the true nature of dark matter? Why does the galactic center contain such dense and intricate motion? Which details are still waiting for the next generation of instruments, the next patient set of measurements, the next calm revision of the map? These are not anxious questions. They are lanterns placed along a long path, and along that path the mind can become very small and very safe, as if it had found just the right place to rest between immensities. Above the stars, beneath the earth, around the galaxy, within the slow settling of breath. The Milky Way's hidden shape is not hidden in order to deny us. It is hidden because perspective has limits, because dust exists, because we inhabit the structure we are trying to understand. Yet the hiding is partial, not total. The galaxy offers enough clues to be known in part, and enough mystery to remain beautiful. That balance is one of the quiet achievements of the universe, and so the night can continue to deepen without concern. The disk turns on. The arms unfurl quietly through distance. The center stays veiled behind dust and brightness. The halo drifts in the outskirts like an old, soft memory. The dark matter halo remains unseen, steady in its influence. The ancient stories keep their place beside the measurements. The sky keeps its calm, and you may keep drifting now with no need to solve the heavens before sleep. The Milky Way remains what it has always been to the human eye and mind: a river of light, a corridor of shadow, a hidden structure slowly revealed, and a familiar vastness that grows only more tender the longer we look at it. So rest within that tenderness. Rest within the old observing mind of your species, which has spent so many generations learning to distinguish a cloud from a galaxy, a myth from a map, a bright band from a disk seen edgewise, a mystery from a truth in progress. Rest within the fact that you are made of the same long story. Rest within the turning. The galaxy does not hurry. The stars do not hurry. The dust does not hurry. The old paths of light and shadow continue their patient work in the dark. And you, held briefly in that ancient, hidden shape, can let your thoughts become lighter now and lighter still until they settle softly into sleep. There is something especially soothing about a galaxy that can be partly seen and partly inferred. It is not a simple object, neatly placed before us like a stone on a table. It is a living arrangement of distances, a layered set of motions, an immense history that cannot be held in one glance. Even the phrase hidden shape feels gentle when applied to the night sky, because it suggests that the universe is not withholding its secrets harshly. It is simply large, and we are simply here, learning at our own calm pace. If you could drift outward above the plane of the Milky Way, above the thin band that stretches across our sky, the structure would begin to clarify. The disk would appear broad and flattened, not unlike the shape of many spiral galaxies seen in other parts of the universe. Yet from within, surrounded by that same disk, the view is different. We see only slices. We see luminous fragments, bright regions, dark lanes, and the blurred thickness of a system that cannot be fully taken in from a single point inside it. It is a little like trying to understand the shape of a forest while standing among the trees at dusk. You can sense the size, the direction, the density, but the whole remains partly suggested. And still, the mind keeps working gently. Long ago, when human beings looked up from rivers, fields, deserts, and stone cities, the bright band across the sky was already ancient. Before telescopes, before charts with precise coordinates, before the language of galaxies, people gave the Milky Way many names. Some saw a celestial road, some saw a spill of milk, some imagined a river of souls, or a seam in the sky, or the ash of a cosmic fire. In different places and languages, the same pale arc inspired different forms of reverence. That is one of the quiet marvels of the night. A single feature of the sky can become many stories without ever losing its mystery. The Greeks, for one, left us the image of milk in the heavens, a fragile and luminous metaphor that survived for centuries. In other traditions, the sky band was linked to a pathway for birds, spirits, or the dead. Among some indigenous peoples, it was understood through accounts of celestial rivers, camps, or tracks left by sacred beings. The details differ, as all honest traditions do, but the mood is often similar. The Milky Way feels like a threshold. It marks a place where ordinary sight gives way to something older, wider, and less easily named. Later, astronomers would learn that the band is not a cloud at all, but countless stars so distant that their light blends into a faint glow. And beyond even that visible glow lies the more subtle structure of the galaxy. Spiral arms, a central bar, a bulging core, a stellar halo, gas lanes, star-forming regions, and a vast invisible halo of dark matter. The visible sky is only one layer. Beneath it are many more. Above it too, in the sense that the same region of space can be read at different wavelengths, each revealing a different quiet truth. Infrared light, for example, can pass through some of the dust that blocks visible starlight. In infrared surveys, the hidden center of the galaxy grows more legible. The dust that once made the inner Milky Way seem almost like a smudged painting becomes less obstructive. New maps emerge. Forms that were dim and uncertain sharpen a little. The bar appears. The bulge becomes more understandable. The spiral structure is traced not as a perfect painted curve, but as a system of regions where gas, dust, and young stars tend to gather along long, graceful, somewhat imperfect arcs. That imperfection matters. Real galaxies are not diagrams drawn by hand. They are shaped by gravity, collision, rotation, collapse, feedback from stars, the slow chemistry of gas clouds, and the long memory of earlier events. The Milky Way has likely absorbed smaller galaxies over billions of years. Some of their stars still travel in streams through the halo, like faint handwriting remaining after a page has been turned. These accretion events are among the galaxy's oldest secrets. They tell us that the Milky Way is not a static island, but a patient result of merging histories. There is a kind of comfort in that. Even on cosmic scales, identity can be layered and composite. A galaxy is not made all at once. It is assembled, it collects, it changes, it keeps some traces and loses others. In the same way, a person is made of many times, many impressions, many inherited things and half-forgotten things. The night sky can feel less lonely when it resembles memory. One of the quietest regions of the Milky Way is the halo, the broad, sparse envelope that surrounds the disk. The halo is not empty. It contains old stars, globular clusters, dark matter, and the faint evidence of former galaxies that were drawn in and stretched apart. Globular clusters themselves are among the oldest known stellar gatherings in the galaxy, compact spheres of ancient stars that seem to have survived from an earlier era. They are like old lanterns suspended at the edge of the main light. Their ages hint at a time when the Milky Way was younger and the universe itself was still becoming familiar with its present form. If one imagines the galaxy as a city, the halo is not the city center. It is more like the outer countryside, the road beyond the walls, the forgotten shrine on a hill, the watchtower at dusk. But that description is only partly true because galaxies are not cities. They are more fluid, more continuous, more immense. Still, metaphor helps the mind rest, and the halo does have the feeling of an outer memory. So many ancient things are stored there in thin, faint forms. The center of the Milky Way is another matter. There the density rises, dust thickens, motion becomes more intricate. At the core lies Sagittarius A, the supermassive black hole around which the central stars orbit. Even this object, so often spoken of in dramatic terms, has a strangely peaceful role in the broader galaxy. It is massive, yes, and powerful in its gravity, but it is not a cosmic monster in the simple way popular imagination sometimes likes to suggest. It is a deep gravitational presence, part of the galaxy's architecture. Nearby stars race on short, swift paths, while larger patterns continue around them, patient and immense. In the language of astronomy, the black hole is not the whole story of the center. The bulge itself is a crowded old region with many stars, with complex chemistry and long-term dynamical memory. A bar extends through the inner disk, influencing how gas flows toward the center and how spiral structure is organized farther out. These features can be charted, modeled, and updated, but they are still, in a sense, only sketches of a much richer whole. The map becomes more detailed year by year, yet the galaxy keeps offering new layers. This is one reason the Milky Way remains so absorbing. It is not distant in the same way some other galaxies are distant. We live inside it. We move with it. We are carried along by its rotation, though we never feel the motion directly in everyday life. The Sun takes roughly 200 and some million years to circle the galactic center, a timescale so vast that it almost loses the shape of time as we know it. Dinosaurs, mountains, oceans, empires, forests, ice ages, and written languages have all come and gone within a single galactic year. The comparison is not meant to unsettle. It simply places human history in a gentler frame. And within that frame, our species has learned to ask old questions very carefully. What is the true mass of the Milky Way? How many stars does it contain? The estimates are huge and necessarily approximate, often given as hundreds of billions, perhaps more than 1 trillion if one counts all the dimmest members and substellar objects. But exactness is not always the point. The point is scale. The Milky Way is so populated that every point of light seems to belong to a larger population, a sort of cosmic kinship. Even the dark regions are not blank. They are often made dark by intervening dust, by the blocking of light, by the presence of molecular clouds where future stars may be forming in hidden warmth. There are places in the galaxy where stellar nurseries glow in infrared, protected by their own dust as new systems gather themselves from cold gas. These regions are quiet in visible light and active in deeper bands. They are reminders that darkness is not always absence. Sometimes it is shelter. Sometimes it is the early stage of light. That idea, too, has comfort in it. The universe does not divide cleanly into visible and invisible, known and unknown, finished and unfinished. It is more gradual than that, more patient. The spiral arms of the Milky Way are often imagined as neat curving ribbons. In reality, they are more complicated. Different traces reveal different patterns. Massive young stars, hydrogen gas, dust lanes, and radio observations each suggest slightly different arm locations and structures. The arms may be long-lived density waves or transient features, or some blend of the two depending on the region and scale considered. Even here, in the very form of the galaxy, there is a kind of living ambiguity. The spiral is real but not rigid. It is more like a pattern in smoke than a pattern in iron. That may be why it feels so elegant. A rigid machine can be understood quickly, but a living structure holds attention longer. The Milky Way is made of motion all the way through. Stars orbit, gas compresses, spiral features shift, small satellites circle and eventually may be pulled in. Dust is stirred by supernovae. Stellar winds carry material outward. The galaxy breathes in the broadest possible sense, not with lungs, but with cycles of creation, dispersal, and reassembly. The motions are slow enough to seem still, yet active enough to shape billions of years. And the history of this understanding is itself a quiet and beautiful tale. For much of human history, the galaxy we inhabit was not recognized as a galaxy at all. It was simply the sky, the Milky Way, the luminous path overhead. Only gradually did the notion arise that some nebulae might be island universes like our own. The famous debates about the nature of spiral nebulae, the careful observations of variable stars, the expanding reach of telescopes and spectral analysis, all contributed to a profound shift in scale. The universe became larger in a way that also made it more intimate. We were not the center of everything, yet we belonged to something much bigger than the old maps had shown. There is an old tenderness in scientific humility. To learn that a familiar band of light is one component of a vast spiral system is not to lose wonder, it is to deepen it. The sky grows more detailed, more layered, more alive. Ancient observers could not have known this exact form of knowledge, but they were already participating in it by attention alone. They looked, they marked, they remembered, they told stories that preserved the sky in human language. In that sense, they too were building the map. Some of the earliest astronomical traditions were closely bound to practical needs. Calendars, planting, navigation, ritual timing, and seasonal prediction all depended on patterns in the sky. Yet it would be a mistake to reduce ancient stargazing to utility alone. There was also contemplation. There was reverence. The heavens were not only useful, they were meaningful. A fixed star rising at a particular season might signal a harvest, but it could also feel like a message from a wider order. The Milky Way, sweeping across the dark, belonged to this same category of meaning. It was part clock, part road, part myth, part question. In some later cultures, the Milky Way became a kind of celestial architecture. It was imagined as a bridge for souls, a crossing place for sacred beings, or a boundary between realms. These stories endure because the sky genuinely invites them. The band of light looks like a path. It cuts across the darkness. It passes above the world with a calm indifference that humans interpret as purpose, and perhaps purpose is not entirely absent from that interpretation if it helps us dwell more peacefully beneath the stars. Stories, after all, are one way of keeping company with the unknown. There is another kind of company in astronomy as well, the company of instruments. Telescopes on mountaintops and in space collect photons that have traveled for vast distances. Surveys map the positions and motions of stars with exquisite patience. Parallax measurements reveal distances by tiny shifts in apparent position. Spectroscopy reads the fingerprints of elements. Radio telescopes listen to hydrogen in the galactic disk. Infrared observatories peer through dust. Astrometry tracks the motion of the sky itself. Each method contributes a layer to the hidden shape. No one method sees everything. That too is instructive. Knowledge is often cumulative. and the universe is willing to reveal itself in pieces. The Gaia mission has brought extraordinary precision to our picture of the Milky Way, tracing positions and motions for vast numbers of stars. With this, the galaxy becomes less like a still painting and more like a living choreography. Some stars move in coherent streams. Others oscillate above and below the disk. Some are remnants of long-ago mergers folded into the present system. The motion map is a history map. Every orbit carries a story of origin, interaction, and drift. This can be a deeply restful thought. Everything has a path. Nothing in the galaxy is simply placed and forgotten. Even the oldest stars continue their quiet trajectories. Even the dust has a direction in the broad sense, shaped by gravity and radiation. The galaxy is not chaotic in the trivial sense of random noise. It is complex, yes, but patterned by laws so consistent that they can be read across light years. The hidden shape is hidden only because it is vast and partly veiled, not because it is arbitrary. And still, mystery remains. Astronomers continue to refine the number and form of the galaxy's spiral arms. They continue to investigate the exact distribution of dark matter in the halo. They continue to examine the nature of the bar, the structure of the central molecular zone, the history of accretion events, the age distribution of stellar populations, the chemistry of different regions, and the dynamics of star formation. Each new data set adds detail, but also new uncertainty. The Milky Way is not solved in the way a short problem might be solved. It is understood in layers, and each layer opens into the next. That is perhaps why it is so easy to fall into thought while looking up at it. The sky does not insist on a final answer. It allows for rest. There are places on Earth where the Milky Way appears particularly bright. In dark rural locations, high deserts, remote mountains, and islands far from city glow, the band can seem almost tactile, as if a faint woven cloth had been stretched across the night. In those conditions, the central bulge may be visible as a bright swelling, and the dust lanes can appear as dark splits running through the light. The Great Rift, a prominent set of dark clouds in the Milky Way's brighter region, can be seen as a kind of wound or channel through the starlight. Yet even the word wound may be too harsh. It is simply structure. Dust is present. Light is blocked. The sky is textured. Sometimes the experience of seeing the Milky Way well is less like observing an object and more like entering a memory. The band overhead has accompanied human beings for so long that it can feel familiar even on first encounter. Perhaps that is because it is one of the few large-scale features of nature that remains visible to the naked eye in its broad form, still legible to anyone with a clear sky and a little patience. A person does not need a degree to feel the scale of it. One only needs darkness and time and a willingness to look. The hidden shape of the galaxy is also shaped by what lies between us and the center. Interstellar dust is made of tiny grains, born in the atmospheres of old stars and in the debris of stellar explosions. These grains absorb and scatter visible light, which is why the galactic plane can look dark in some regions, even though it is rich with stars. Dust is often associated with obscurity, but in astronomy it is also a source of formation. Dust grains help cool gas, enabling molecular clouds to collapse into denser regions where stars can be born. So the same material that hides can also nurture. The galaxy is full of these double roles. In old stories, too, what obscures and what reveals are often the same thing. A veil can conceal a face while also drawing attention to the face beneath. A foggy road can slow the traveler while making the lanterns brighter. A mystery can be frustrating and beautiful in equal measure. The Milky Way's hidden shape works this way. The dust obscures the center, but it also reminds us that the galaxy is physically real, materially rich, and not merely a pattern of lights pinned to a sky. Far from the central regions, the outer disk of the Milky Way grows more tenuous. Stars become fewer. Gas thins. The rotation curve, one of the key ways astronomers infer the presence of unseen mass, remains puzzling in a way that led to the dark matter hypothesis. The outer galaxy moves as if more mass exists than visible matter alone can explain. Thus, the hidden shape extends beyond what the eye can detect. It is not just that the galaxy has arms and a bar and a halo. It is that much of its total structure is subtle, inferred through motion and gravity. The visible galaxy is, in an important sense, only the luminous edge of a larger arrangement. That larger arrangement has inspired many generations of researchers. But it also invites a kind of philosophical rest. If so much of reality is unseen yet measurable through its effects, then perhaps the world is always fuller than the immediate view suggests. A calm person may take comfort in this. There is no need to possess everything directly in order to know it is there. The night itself is proof of that. You cannot hold the sky in your hands, and yet its presence is unmistakable. Near the center of the galaxy, the environment becomes especially rich in matter and motion. Molecular clouds crowd together in the central molecular zone. Star formation proceeds under conditions unlike those in the quieter outer disk. Energetic events leave their signatures. Magnetic fields thread the region. SGRA sits at the core, and nearby stars, some very young and some very old, move in orbits that have helped astronomers measure the black hole's mass with great confidence. Yet even there where the gravitational influence is most concentrated, there is a strange serenity in the scale. A black hole may sound absolute, but in the life of a galaxy it is one element among many. There are also the relics of ancient collisions. The Milky Way has not grown alone. It has cannibalized, absorbed, and blended with smaller systems over cosmic time. The Sagittarius dwarf galaxy, for instance, is being torn apart as it orbits and sinks through the Milky Way's halo, leaving streams of stars as testimony to its slow dissolution. Other mergers occurred long ago, so long ago that their sources are now difficult to distinguish except through careful stellar archaeology. This phrase, stellar archaeology, has a particularly quiet beauty. It suggests that stars can be studied like potsherds, ruins, buried roads, and inscriptions. The galaxy has a past, and that past can be excavated. Ancient cities on Earth sometimes lie beneath later cities, layered and partially forgotten. The Milky Way has its own layered past, though its strata are not stone but stars, motions, and chemical fingerprints. Older stars tend to have fewer heavy elements because those elements are produced over time by successive generations of stellar evolution. So by studying metallicity, astronomers read age and ancestry in a broad sense. The galaxy is a record keeper, and each star carries a chemical memory. This is quietly moving. A star is not only a light in the sky, it is also a document of earlier cosmic work. Some of its atoms were made in earlier stars that died before our sun was born. The calcium in bones, the iron in blood, the oxygen in breath, the carbon in living tissue, all were once part of some earlier stellar history. This fact is often repeated because it is true, and because truth repeated slowly can become comforting. We are made from old light. We belong to a long chain. That chain reaches back into the galaxy's hidden shape as well. The sun itself is not at the center, but in a calmer region of the disk, within one of the spiral structures, at a distance that lets life endure on a small world with liquid water and seasons. The galactic neighborhood matters, though not in an anxious way. Catastrophic events are possible in the universe, but the local environment has been stable enough for life to emerge and continue. The Milky Way's structure may influence the long-term radiation environment, the frequency of nearby supernovae, and the distribution of habitable zones in a broad statistical sense. Yet here we are under a sky that has allowed stories, tools, and sleep. The old sky watchers could not have known about habitable zones or stellar nucleosynthesis. Still, they understood something essential. The heavens had order. They could be followed. They returned. The seasons changed in relation to them. The Milky Way itself, though diffuse and less practical than the sun and moon for daily timing, still formed part of the same great overhead order. Its appearance in the year, its relation to darkness, its changing visibility with season and latitude, all made it a quiet marker in human life. In one season it arches high and clear, in another it seems more faint or differently placed. The band remains, but the experience of it shifts, as if the galaxy were breathing with the year. There is a slow pleasure in noticing such things. The sky is not the same every night, though it feels constant. Clouds pass, the moon grows and thins, planets wander. The Milky Way shifts its angle across the seasons. In the northern and southern hemispheres, its appearance changes with latitude. Some parts are more prominent from one half of Earth than the other. The great center is seen best at certain times of year and from darker locations. All of this means that the hidden shape is not merely an abstract model. It is a lived experience tied to place, time, and weather. And beyond the Milky Way, there are many more galaxies, each with its own form and history. Some are grand spirals like ours, some are lenticular, some are irregular, some bear scars of collisions, some glow softly in clusters. Yet our own galaxy remains singular in one important way. It is the one through which all our observations are filtered from the inside. We cannot step away to view it as a whole without first leaving it, and even then our understanding would travel with us. This makes the Milky Way unusually intimate. It is both home and subject. Home is a useful word here if we treat it gently. The galaxy is not a home in a domestic sense. It does not shelter us the way a house does, but it does provide the larger setting in which our actual homes exist. It is the broader neighborhood of the Earth. It is the shared drift of the sun, planets, comets, and interstellar material. In that sense, every human dwelling, from palace to hut to observatory to monastery, has always sat inside a much greater architecture. The stars above the roof are part of the same system that helped shape the roof's builders and the land beneath their feet. Some cultures developed extraordinary precision in reading the sky without the tools of modern astronomy. They used shadow lines, star risings, lunar cycles, and seasonal markers to create calendars of remarkable sophistication. Their observations were often embedded in ritual and memory, which kept them durable across generations. The Milky Way sometimes appeared in these systems as a navigational guide or ceremonial pathway. Such knowledge deserves to be remembered not as quaint prelude, but as part of the long human effort to understand the heavens. The galaxy was known first as story, then as pattern, then as structure, and it remains all three in different ways. One could spend a long time simply reflecting on the phrase hidden shape. It implies that there is a real form beneath surface appearance, but that the form must be discovered through patience. It also suggests humility. Hidden does not mean absent. Shape does not mean simple. The Milky Way contains regions of dense star formation, regions of old stars, regions of dust, voids between clouds, orbiting satellites, tidal streams, and the gravitational influence of a dark halo that no eye can see directly. The galaxy's form is partly luminous, partly inferred, partly remembered, partly still in question. And perhaps this is why it fits so well into bedtime thought. The mind before sleep often prefers gentle incompleteness. It is easier to drift when not every edge has been sharpened. The galaxy offers that kind of spaciousness. One can think of its spiral arms without counting them. One can think of the center without approaching it. One can think of the halo as a soft envelope of old stars. One can think of the dark matter halo as a steady, invisible architecture holding the system together without needing to picture it exactly. The imagination can rest in suggestion. There are also the small details that make astronomy feel human. A photon leaving a distant star may travel for thousands of years before reaching a telescope mirror or a human retina. A measurement made on one night may refine a model that has already been revised many times. A map of the Milky Way may include corrections for dust, extinction, parallax biases, and selection effects. Behind each polished result is a patient accumulation of uncertainty, error bars, and careful skepticism. This is not a flaw in the science. It is part of its grace. Knowledge that respects uncertainty is often more lasting than knowledge that pretends certainty too quickly. The same could be said of old myths. They did not solve the sky, but they honored it. They offered shape where none was fully known. They allowed wonder to remain alive while explanation was incomplete. In some tales, the Milky Way was a path of divine beings or a river crossed by heroes. In others, it was a scar, a seam, or a shining dusting of celestial flower. These images do not compete with astronomy. They belong to a different layer of attention. One layer measures, another remembers, another comforts. The sky can bear all of them. There is even a certain beauty in the fact that the galaxy's hidden shape depends on our viewpoint. From within, structures overlap. From above, if we could stand there, the grand design would appear more apparent. This difference reminds us that perspective is not just a philosophical idea, but a physical one. The same object can look entirely different depending on where the observer stands. The Milky Way is the same galaxy in either case, but its legibility changes. So much of life works this way as well. A problem seen from close range may appear tangled. From a little distance, it may reveal an arrangement. A memory seen in the present may seem one thing, from later years it may become another. Distance can clarify without diminishing, and the galaxy itself is full of distance. The nearest stars are still far. The spiral arms extend across tens of thousands of light years. The halo reaches farther still. The outermost traces, perhaps from old mergers or faint satellites, blur into the surrounding space. Yet even this vastness has edges of comprehension now. Not everything is hidden. The map is already beautifully advanced. It is only that the universe continues to be bigger than the map. That is not a disappointment. It is an invitation. The invitation is to continue learning slowly, without urgency, to notice how the band of the Milky Way is brighter where the bulge thickens, to appreciate how dust makes dark rifts across the luminous plane, to remember that the galaxy's visible starlight is only a fraction of its total matter, to think of the invisible dark matter halo as a kind of scaffolding of gravity, inferred through the motions it shapes, to imagine the ancient streams of stars circling the halo like soft threads pulled from a larger cloth, to sense in all of this a vast calm process that does not ask us for anything except attention. Attention can be a form of rest when it is gentle, so the sky may now become simpler again in the mind. The center of the galaxy remains distant. The spiral arms continue their long arcs. The halo remains faint and old. The dark matter stays unseen. The sun keeps its place in a quieter part of the disk. The Earth continues its small, faithful rotation. The night deepens. The ancient stories wait nearby like folded cloth. The measurements remain ready in their notebooks and archives. The stars remain themselves, and you can let all of it move on without effort. Let the Milky Way be a band of light across darkness. Let it be a disk, a bar, a bulge, a halo. Let it be visible stars and hidden mass. Let it be dust that obscures and dust that helps stars begin. Let it be ancient mergers, old streams, forgotten companions. Let it be the place where our sun travels and where our species has learned to ask questions. Let it be a mystery that is not threatening, only deep. Let it be enough for tonight that the galaxy exists in this way, patient and partially veiled, known in part and loved in full. The mind does not need to solve the heavens before sleep. It only needs to feel their steadiness long enough to soften. The Milky Way keeps its hidden shape without strain. Its structure persists through every season, every century, every generation of observers. One day there may be even finer maps, even subtler measurements, even clearer understanding of how the spiral arms are arranged, how the bar channels matter inward, how the halo records ancient collisions, how dark matter shapes the whole. But for now and for this quiet hour, the beauty lies in the gradual revealing. So let the gradual revealing slow now. Let the questions become dimmer. Let the stars above the disk seem farther and friendlier. Let the unseen parts remain unseen for the moment. Let the known parts remain softly known. and let yourself drift within that gentle balance, as if you were carried not by urgency, but by the long, calm rotation of a galaxy that has been turning since before anyone on Earth ever gave it a name.